All right, so this is factoring and solving polynomial equations. There is an opener where it's just polynomial long division, or you can use synthetic division to divide this. So I'm not going to show you the opener because we already went through that. That was last chapter. And from the looks of it, it doesn't look like it has a correlation to any of the rest of the notes. So I'm going to skip that. And if I need to come back and do it, I will. Okay, so it looks like the first four here are problems that you've already done before. So this is factoring, and then the bottom is solving. So it says factor each, okay? So when factoring, the first thing you always look for is a GCF, okay? So these are things that you already learned. So if you look here, there's three terms. These three terms have nothing in common. So there is no GCF. So now if it's three terms, what we do is we use this organizational X to factor this. This first coefficient is A, the second coefficient is B, and the third coefficient is C. What we do to organize this is we put A times C up here, so whatever A times C is. So 2 times negative 21 is negative 42. And then the B value goes down here, which is 11. So what we're doing is we're looking for two numbers that when you multiply them, you get negative 42. And when you add them, you get positive 11. So people start throwing out numbers. So someone will say 7 and 6. 7 and 6 don't have, if you add them, you get 13. If you subtract them, that you get 1. So that's not going to work. So if you can't think of the numbers right away, start from the beginning. Say 1 and 42. That's not going to work. 2 and 21. That's not going to work. 3 goes into 42, but how many times? So 42 divided by 3, if you check it out, 3 goes in there once. A remainder of 1, so that's 14 times. 3 and 14 will give you 11. So I'm going to make one of these numbers 3, one of them 14, and then they have to add to give me, multiply to give me negative 42. So one of these has to be negative, and it has to add to give me 11. So I'm going to make the 3 negative. That adds to give me negative or positive 11 now. Now the really important part is making sure that you divide by the A value. So you have to divide by the A value, which is 2. Now you're going to look to see if either one of these fractions is simplifiable. Negative 3 over 2 is not simplifiable, but 14 over 2 is simplifiable. 2 goes into both, 7 times and 1 times. Notice I'm leaving it over 1 because that's going to help me write my factors. So now what you're going to do is you're going to write them upside down. Okay, so this right here, you're going to put an X down here, and you're going to put an X down here. So your first factor, and you're going to write it upside down, is 2x minus 3. And once again, that comes from this 2x and then going this way, minus 3. This one is a 1x plus 7. Instead of writing 1x plus 7, I'm just going to write x plus 7. And now that is factored. All right, let's look at the next one here. So the next one, if you look at it, there's no GCF. It is 3 terms again. Now, if I made that X again right here, and I had to do 4 times 81, my numbers are getting really big. So you're supposed to recognize this as a special factoring pattern. This is a perfect square. This is 2x squared, and this is a perfect squared, which is 9 squared. And if you multiply those two, 2x squared times, which is 4x squared, times 9 squared, or times 9, you get 36. So this is a special factoring pattern. So what you can say that this multiplies to 2 sets of parentheses. The first 2 terms multiply to give you 4x squared, which is 2x and 2x, and the last 2 multiply to give you 81, which are 9 and 9. If you check outer and inner, that's 18x and 18x, which is 36x. Another way of writing this is 2x plus 9 quantity squared. So either one works. All right, the next one, first thing we're going to do is look for a GCF. 9x squared and 100 have nothing in common, so there is no GCF. Now, when there's 2 terms, you're going to see if it's a difference of squares. So you ask yourself, is this a perfect square? Is this a perfect square? It is. It's 3 squared. Is this a perfect square? It is. It's x squared. Is this a perfect square? Yes, it is. It's 10 squared. And is it a difference? Yes, it is. So this has a special factoring pattern. So once again, it factors to 2 sets of parentheses. These 2 terms have to multiply to give you 9x squared, and they have to be the same thing. So it's 3x and 3x. And then these two terms have to multiply to give you negative 100, and they have to be the same number but opposites. So that's plus 10 and minus 10. If you look at outer and inner, outer is 30x and inner is negative 30x, and those cancel, and that's why there's no middle term here. All right, last one. First thing I do is I look for a GCF, and this time there is a GCF. These two terms have a 3 in common, and they have an x in common. So I'm going to factor out the 3x. Now when I'm factoring it out, I'm dividing it out. So if I take a 3x out of a 3x squared, I have x left. And if I take a 3x out of a negative 27x, I have a minus 9 left. Now if you look, this is not factorable anymore, so you have factored this completely. All right, so those are factoring that you have learned before. So now there's new factoring patterns that he wants to talk about. The first one is the factoring pattern that you have to memorize is the sum or difference of cubes. The mnemonic device to help you remember what to do is SOPs, okay? So I'll explain what SOPs is that helps you in just a second. So the special factoring pattern, when you have a perfect cube, so that's something cubed plus something cubed, the first thing you're going to do is copy the base, okay? That's going to be your first factor, and this is always going to be a binomial, so something plus something or something minus something. Your base would be a plus b, so I'm going to copy that down. That's my first factor. Your second factor is a trinomial, so it's 3 terms, and SOPs helps you remember how to get those 3 terms. So the S stands for square. Let's see, is it going to let me switch colors? There we go. It stands for square. So what you're going to do is you're going to square the first terms. The first term is a right here. You're going to square it, and that's a squared. The O stands for opposite. So you're going to take the opposite of this sign, and that's minus. This P stands for product, meaning multiplication. So you're going to multiply these two numbers. A times B is AB. This P stands for plus, because you're always going to use a plus sign. And then this S stands for square also, but now you're going to square the last term. So this is B squared. And that's what it factors to. That's a special factoring pattern. Just like a difference of squares is A plus B times A minus B. So same idea here. If it's A cubed minus B cubed, first thing you're going to do is copy the base, which is A minus B. That's going to be your binomial. And then your trinomial, use SOPs. S stands for square the first term, A squared. O stands for opposite, which is a plus this time. P stands for product, multiply these two. A times B is AB. P stands for plus. S stands for square the last term. B squared is B squared. And that's what it would factor to. So here's 3 examples of either sum of cubes or difference of cubes. So right now you might not be recognizing this as a sum of cubes because this isn't written as a number cubed, but this is. So we want to rewrite the 64 as a cube. So what number cubed is 64? It's 4 cubed. So we say what's A? A is x. What's B? B is 4. So now what we're going to do is we're going to use our special factoring pattern. We're going to copy the base, x plus 4. We're going to square the first term. So notice I don't even need what's up there anymore. Square the first term, that's x squared. O stands for opposite, so that's minus. P stands for product, multiply those two, 4x. P stands for plus. S stands for square the last term, so 4 squared, 16. And that's it factored completely. You can't do anything else with it. All right, here's the next one. This is not written as a perfect square, so I want to rewrite it as a perfect square. That's a 2 cubed. Then I have x cubed minus, and 27 is 3 cubed. So I have A is 2x. And if you're like, where did that come from? Everything but the cubes. And B is 3. All right, so now I'm going to get my special factoring pattern. I'm going to copy the base. This is not 2x plus 3. It's 2x minus 3 because this is a minus right here. All right, so now SOPs. Square the first term. So 2x quantity squared, square the 2, square the x squared, 4x squared. O stands for opposite, so opposite of negative is positive. P stands for product, multiply those two, 6x. Plus sign, square. Square the 3, 9. And there's your polynomial completely factored. All right, one more. 125 is 5 cubed. If you want to pause the video and try this one, it's a good idea to do that. This is x cubed minus 8 is 2 cubed. So A is 5x, B is 2. Copy the base, 5x minus 2. Once again, it's minus because of this sign right here. And now you're going to use SOPs to get the rest of it. So square the first term. Square 5, 25, square x, x squared, 25x squared. Opposite is plus. Product would be 10x. P stands for plus. Square the last, which is 4. And now you're completely factored. Okay, next factoring method is for when you have 4 terms. So when you see a polynomial with 4 terms and the directions say factor, you are going to try to factor by grouping. So here's how factor by grouping works. You're going to group the first 2 terms together, and you're going to look for a GCF. So if you look, these 2 terms have an x squared in common, and then you're going to factor out that x squared, and you get x minus 2. Now you're going to do the same thing to the second 2 terms. So I'm going to change colors just so you can see what I'm factoring here, or at least I'm going to attempt to change colors. All right, so now what you have to see is what's the GCF of these 2. These 2 have a negative 9 in common. Now when you factor out, you better get x minus 2. Factor out the negative 9, you get x. Factor out the 18, you get negative 2. So now you're going to write your 2 factors. Notice these have an x minus 2 in common. So you're going to factor the x minus 2 out of each one of those. So you have x minus 2. And now you're going to write your other factor, which is made up of the x squared minus 9. Now, I would box this and say we're all done. But if you look, this is still a quadratic, and this quadratic is still factorable because it's a difference of squares. So I'm going to keep the x minus 2 in my answer. And then the x squared minus 9 I'm going to factor. This is a perfect square, this is a perfect square, and it's a difference. So I'm going to factor it. The first 2 terms have to multiply to give me x squared, which is x and x. And the second 2 terms have to multiply to give me negative 9, which is positive 3, and negative 3. And there I'm completely factored. Now I want you to realize is that if this was a plus 9, you'd be done, because x squared plus 9 is not factorable. If this was an x squared minus 8, x squared minus 8 isn't a difference of squares either. So it would not be any more factorable. But the fact that it was an x squared minus 9, it was still factorable. All right, let's look at the next one. So 1, 2, 3, 4 terms. So I'm going to group the first 2 together, and I'm going to look for a GCF. They have a 3x squared in common. Factor out the 3x squared. I have x minus 2. And now I need to group these 2 together and see what the GCF is. If you look, the only thing they have in common is a 1. I still want to factor out that positive 1, and I have x minus 2. Notice they have an x minus 2 in common, so I'm going to write down the x minus 2. And now I'm going to write my other factor, which is 3x squared plus 1. So the 3x squared plus 1 is still a quadratic, but it's not a difference of squares. It's not a sum of cubes. It's not a difference of cubes. So this is as far as we can go here. And that's your answer. Oops. All right, one more. 4 terms, group the first 2 together. And if you want to pause the video and try this one yourself, it's a great idea. They have a GCF of x squared, and I have x plus 1 left. These 2 terms have a GCF of negative 9. And if this number is negative, you want to factor the negative out no matter what. All right, so factor out the negative 9, and you have x plus 1. Once again, these 2 have to match. So if you only factored out a positive 9, they wouldn't match. So I have x plus 1 and an x squared minus 9. Once again, that x squared minus 9 is factorable. It's a difference of squares. So I'm going to factor it to x plus 3, x minus 3. And this is that completely factored. Okay. Next, it says factoring polynomials in quadratic form. So this is when we have 3 terms and there's a quadratic involved. So I'm assuming. So it says GCF, number of terms, etc. Okay, so we're just going to do it just like we did the warm-up here. So we're going to look for GCF. This term, and this term. They don't have any x's in commons. They don't have any constants in commons because their coefficients are 1, 4, and 21. So I say, all right, well, you're still 3 terms. So when I have 3 terms, I'm going to use this organizational x. A times c goes up here. So a is 1, c is negative 21, so that's negative 21. B goes down here, b is 4. All right, so now I need 2 numbers that multiply to give me negative 21 and add to give me 4. 7 and 3, and I'm going to make the 3 negative. That'll give me a positive 4. Don't forget to divide by your a value, which is 1. All right, and now I'm going to write my factors. This time it's multiplying to give me an x to the 4th. So I know this is an x squared and an x squared instead of an x and an x. So now I'm going to write it upside down. Instead of writing 1x squared plus 7, I'm going to write x squared plus 7. And this one right here is an x squared minus 3. Now I got to look to see if it's still factorable. This is a perfect square, but this isn't, and it's not a difference. So no, that's not factorable. This is a perfect square. This is not a perfect square. So this is not factorable either. So this is all done. All right, so let's look at the next one. First thing we're going to look for is a GCF. If you look at these 3 numbers, they have a 3 in common. And if you look at the x's, they all have an x in common. So I'm going to factor out a 3x. Once I do that, I have x to the 4th minus 5x squared plus 6. All right, if you look at what's left behind in this parentheses, this is still a trinomial, so I have to see if this is factorable. So I'll just hide that 3x for a second, but it's still in my answer. So I'm going to make my organizational x. I'm going to do a times c. So if you notice right here, a is 1. Come on, color. A is 1. B is negative 5. C is 6. So a times c is 6. B is negative 5. 2 numbers that multiply to give me 6 and add to give me negative 5. So 6 and 1 multiply to give me 6. If I make the 1 negative, that doesn't multiply to give me 6. So it's not going to be a 6 and 1, but don't forget that there's 3 and 2. 3 times 2 is 6. If I make them both negative, negative 3 and negative 2, that's going to give me a positive 6, and they add to negative 5. Divide by a, which is 1. And then once again, this is an x to the 4th, so this is an x squared and an x squared. So now I'm going to write my factors. I'm going to zoom back out. Don't forget your 3x. And then I have an x squared minus 3, which is not factorable because it's not a difference of perfect squares because 3 is not a perfect square. And x squared minus 2, which is also not factorable because 2 is not a perfect square. So there's my final answer. Last one in this section, first thing I look for is a GCF, and I notice they have an x squared in common, so I'm going to factor out the x squared, and I have x to the 4th minus 16. So now I look at this binomial that's left, and I'm going to see if it's a difference of squares, a difference of cubes, or a sum of cubes. If you notice, both x to the 4th and 16 are perfect squares. X to the 4th is x squared squared, and 16 is 4 squared, so this is factorable. So I'm going to write down the x squared, 2 sets of parentheses. The first 2 terms have to multiply to give me x to the 4th, so that's x squared and x squared. The second 2 terms have to multiply to give me negative 16, be the same number but opposites, so plus 4 and minus 4. Now, I would be done if it wasn't for this x squared minus 4. X squared minus 4 is still factorable because it's a difference of squares. X squared plus 4 is not factorable because it's a sum of squares, and sum of squares isn't factorable. So I'm going to write my x squared down. I'm going to write the x squared plus 4 factor down. And now I'm going to factor the x squared minus 4. These 2 numbers have to multiply to give me x squared, so that's x and x. And the second 2 numbers have to multiply to give me a negative 4, so that's positive 2 and negative 2. And now it's completely factored. Okay, last but not least, there's solving a polynomial equation. It says factor, then use the zero product property. So solving using a polynomial equation, so first off, in order to solve by factoring, it has to be equal to 0. So this is not equal to 0, so the first thing I'm going to do is get it equal to 0 by subtracting negative 14x cubed from both sides and then writing it in standard form. So I have a 2x to the 5th minus 14x cubed plus 24x equals 0. So now I'm going to try to factor the left-hand side. Please make sure you're keeping it equal to 0 because the other ones weren't equal to 0, so we weren't losing that. This one we have to solve when we're done. All right, so first thing we're going to do is look for a GCF. If you look, they all have a 2 in common and an x in common, and that's on the left-hand side. So I'm going to factor out a 2x. I have x to the 4th minus 7x squared plus 12, and then equals 0. Now I'm going to look to see if this is still factorable. So it's a trinomial, so I'm going to make my little organizational x. I'm going to do a times c. Remember, I'm just looking at the trinomial. So a is 1, c is 12. 1 times 12 is 12, and then b is negative 7. 4 and 3 multiply to give me positive 12, but they don't add to give me negative 7. So I'm going to make both negative, and now it works. Don't forget to divide by the lead coefficient of 1, and that's going to be an x squared and x squared again because that's an x to the 4th. So I'm going to write my new factors. I have a 2x. I have an x squared minus 4, and I have an x squared minus 3 equals 0. X squared minus 4 is still factorable because it's a difference of squares. X squared minus 3 is not factorable because 3 is not a perfect square. So I have 2x times x plus 2 times x minus 2 times x squared minus 3 equals 0. So now I can set each factor equal to 0 and solve. So I have 1, 2, 3, 4 factors. So we're going to set each one equal to 0 and solve. 2x equals 0. X plus 2 equals 0. X minus 2 equals 0. And x squared minus 3 equals 0. So the first one here, I have to divide both sides by 2. And I get x equals 0. There's my first solution. Here I have to subtract 2 from both sides, and I get x equals negative 2. Here I have to add 2 to both sides, and I get x equals positive 2. And on the last one, I have to add 3 to both sides. I have x squared equals 3. And then I have to solve for x, so I have to square root to get x by itself. Now, whenever you add a square root to an equation, you have to remember to account for the positive and negative solution. So I have 2 more solutions. X equals positive root 3 and x equals negative root 3. So there's 5 solutions total to this 5th degree polynomial, and there's all 5 of them. All right, let's try another one here. It's already equal to 0, so now I can try to solve by factoring. So the first thing I'm going to do is look for a GCF. So I'm going to say, okay, do these two terms have anything in common? They do. They have a 5y in common. So I'm going to factor a 5y out of each of them. I then have y to the 4th minus 5 goes into 80 16 times, and then y would factor out equals 0. Now I'm going to look to see if it's still factorable. So I'm going to look at this right here, and I notice that it's a difference of squares. So this is still factorable. So I have 5y times, I'm going to put my 2 sets of parentheses. These two have to multiply to give me y to the 4th, so y squared and y squared. And the next two terms have to multiply to give me 16, so positive 4 and negative 4. Now I'm going to look to see if either of these two are still factorable. Y squared minus 4 is a difference of squares, so it's still factorable. So I have 5y times y squared plus 4, and then I'm going to factor y squared minus 4. Y times y will give me my y squared, and then positive 2 and negative 2 will give me my negative 4. So now that I'm down to linear terms, it's not factorable anymore. And just like the last one, I can set each factor equal to 0 and solve. So 5y equals 0, y squared plus 4 equals 0, y plus 2 equals 0, and y minus 2 equals 0. Now you might be saying, when do I set it equal to 0 and when I don't? It's when it's an equation and it's equal to 0 that you do that. This wasn't equal to 0, but we needed to get it equal to 0, and then we set each factor equal to 0. All right, so go ahead and solve each one of these. Divide by 5, and I get y equals 0. Subtract 4 from both sides. I have y squared is equal to negative 4. And now I need to square root both sides. Don't forget to do plus or minus. And I have y equals plus or minus. And then the square root of negative 4 is 2i. I'm assuming you guys have learned imaginary numbers already. I'm not positive, though. Subtract 2 from both sides. You get y equals negative 2. And add 2 to both sides. And you get y equals positive 2. Now, if you guys didn't learn imaginary numbers yet, then you wouldn't include imaginary answers. If you have, then you do. I'm assuming you did. I'm almost positive. All right, last one. This is a trinomial. It's already equal to 0, so I'm going to try to factor it. I look for a GCF. These three terms have nothing in common. So I'm going to use my organizational X to factor it since it's 3 terms. A is 1, C is 20. A times C is negative 20. B is 1. So 2 numbers that multiply to give me negative 20 and add to give me 1 are positive 5 and negative 4. Divided by my lead coefficient, which is 1. And since this is an x fourth, this is the x squared and an x squared. So I have x squared plus 5 times x squared minus 4 is equal to 0. X squared plus 5 is not factorable because it's not a difference of squares, but x squared minus 4 is. So I have x squared plus 5 times x plus 2 times x minus 2 equals 0. And now I can solve each one of these equations. I'm positive you've learned imaginary numbers already because I was listening to someone do final exam review today, and they were talking about them. Okay, so now I need to solve the first equation. Subtract 5 from both sides. I have x squared equals negative 5. Square root to solve, so I'm going to do square root plus or minus, square root plus or minus. I have x equals plus or minus. I have the square root of negative 5. It's a square root of negative number, so I know I is in my answer. But now it's just root 5, and I don't know the square root of root 5, so I just leave it as root 5. So it's plus or minus I root 5. Here, subtract 2 from both sides, and I get x equals negative 2. Here, add 2 to both sides, and I get x equals positive 2. And there are my solutions. All right, that's it for these notes. Go ahead and try the homework associated with it.